Hello and welcome back to another BodgedButWorks project. So here's the story. My flatmates and I wanted to make a birthday present for another flatmate, and we decided to make him a soundboard. Now, of course, there are already smartphone applications for this, for example, instant buttons, if you remember that one. But we found it's always a bit tedious to have to get your phone out, unlock your phone, start the app, and then search through the long list of samples to the one you want to play at that moment. Instead, we wanted him to have a handy little box that he could always carry with him and that had its own autonomous power supply, and where you could just press a button and it would play a sample. The first thing we did was think about the housing. We decided to make it out of wood and plexiglass, in contrast to, for example, just 3D printing it to give it a more exquisite look and feel. The electronics inside this little box are fairly simple. Everything is powered by a very slim power bank that I got off of Amazon and that fits in here quite nicely. Underneath this power bank there's an Arduino microcontroller that simply reads the signal from the 10 buttons around the sides of this housing and then plays samples directly off of an SD card. That means you can exchange samples at will by just switching them out on the SD card. The loudspeaker we had laying around from an old smartphone, and it gives us a pretty clear and loud sound. Yeah, and that's basically it. The rest is wiring and details. That's all there is to this little soundboard. Before I designed the housing in my CAD software, I sketched out all the individual electronic elements in my CAD software, and that allowed me to kind of align everything beforehand and then design the wooden housing around everything so everything would fit inside and also be fairly compact. The push buttons are facing towards the sides of this housing, and that gives us an even smaller form factor, and also you don't accidentally press the push buttons if you have something else in your pocket besides the soundboard, for example, keys or your smartphone. After designing the 3D housing and the lid, I exported 2D views of all of the sides because I wanted to mill them with my Shaper origin later on. Next, I imported them into Inkscape to prepare them for cutting. And there I had the first mishap in a long line of mishaps for this project, because I realized my CAD software was only able to export these 2D views as individual segments. So each line, each polygon, each arc was a single element, a single vector element in Inkscape, and I had to connect those all manually to get back to closed shapes where the Shaper origin would understand where to cut inside and outside of the shapes. So that was really tedious, but I got it working in the end, and then the files were ready for cutting. I cut this wooden bottom part of the housing out of acacia wood, and that worked pretty well despite the fact that we have a wall thickness of just 3 millimeters. I used the 3 millimeter cutter included with Shaper origin to take out most of the material inside the box, and then switched to my 1.2 millimeter bit to finish the details and small lines. I also used the 1.2 millimeter bit to make the slots for the loudspeaker, the on and off switch, and the SD card. Meanwhile, my flatmate, to protect his identity, I shall call him Dirk, prepared all the electronic components, cut the wires to length, and soldered everything together. After milling all the sides of this wooden bottom part, we started testing our button flaps. I designed these slots into the sides of the wooden box, and we hoped that they would be flexible enough to be able to press on them, and they would bend enough to press onto the push buttons located directly behind them. But that did not work as intended. Our problem was that they were way too stiff, so even if you pressed on them with considerable force, They wouldn't bend enough to trigger our buttons. We transitioned to plan B and started drilling away some of the material behind the flaps to try and get the wall thickness down and to hopefully get them to bend a bit better. Unfortunately, this type of wood seems to be too brittle for that, so when we reached the wall thickness that we needed to get the wood to bend at all, the flaps started tearing off one by one. We had actually prepared a plan C for that, and that was to apply a flexible and kind of rubbery glue to the point where the flap meets the rest of the housing. And to date, that system is working okay, so the flaps aren't falling off anymore, and it gives us the hinging characteristic that we need to trigger our buttons. Now it was time to test the electronics, and thankfully that worked pretty well out of the box. We were able to press the buttons and get some of our samples played. We started gluing in the components into the housing, and the first part on our list was the SD card holder that we tried to fixate with a drop of hot glue. We applied a small drop of glue to the SD card holder and pushed it into the housing. And for whatever reason, this small drop of hot glue was enough to break the SD card holder.
It was at this moment that Nathan knew he fucked up.
We weren't really sure what had happened. Some of the glue must have gotten into the intricate mechanics of this SD card mechanism. It's one of those models where you press the SD card in, and then when you push on the card again, it should release the card. And it didn't do that anymore in our case. So we were forced to rip the part back out and try to reverse engineer what had gone wrong. We weren't able to find out what had gone wrong because inside of this SD card reader module there's a few really small parts. For example, a spring that we lost in the process of opening it up. And so, we were stuck with a stuck SD card and had to figure out what to do next. I ended up digging through my supply of other PCBs and old electronic devices, and we did actually find a small PCB that coincidentally had the same SD card reader on it. And we were able to salvage that and replace our broken one with that, and thank God we found that, because otherwise we would have had to cope with that weird not releasing characteristic and pulling it out with a string or something. So I'm really happy that we found that new one, and now we have a really satisfyingly clicking mechanism, and it's back to working 100%. After that mishap that took us about 90 minutes to fix, we continued gluing everything else in, and thankfully that worked just fine. While trying to put everything together for the first time, we realized that we had overestimated the limited space below the power bank inside the housing. I really like to design my stuff pretty compact, and I likely forget the wiring that has to go in there as well. So what we had to do to be able to close the housing at all was to desolder most of the wires, cut them down to a new length, and then solder them back. So sorry to my two flatmates who had to do that over the course of like 3 hours. Next time I'm going to plan the wiring a bit shorter. Fun fact, we even had to desolder the reset button on the Arduino microcontroller, because after putting everything together and jamming it into that tight space, we kept pressing that reset button, and of course the device won't work if the reset button of that Arduino is pressed all the time. So we just had to take it out, and after that we were able to just push everything together. And I mean, guys, it's a prototype, we're allowed to do that. Next, I manufactured the lid for the system. We used a sheet of acrylic glass that my flatmate had laying around. I think it was originally a laptop display protector or something, and it has these white laser dots inside, but that was fine because they give us a cool look, and I mean the sheet was free and it's also fairly flexible, so it was a pretty ideal choice for this project. So I started making the first lid out of this sheet of acrylic glass. Unfortunately, I had double-sided taped this sheet down so well that after milling everything, I wasn't able to get that part off of my workspace without breaking it. And you cannot guess how agonizing it is to have a perfectly milled part, you're ready to take it out and test it, and then you realize it's stuck down so well that no matter what tools you use, you're going to break this part and you have to start over. And that's exactly what I did. I tried it again, and this time I double-sided taped it down with just 2 really small strips of tape, and I was able to take that sheet of acrylic glass out after milling without breaking it. So, lesson learned here, do not double-sided tape your parts down too well if they're out of a fragile material that sticks as well as acrylic glass to your workspace. At this point, we had everything glued in, the power bank went on top of everything flush, and we put the lid on top, and it was looking great already. Now it was time to write some software. We spent quite some time discussing what features we wanted for the soundboard, and I think we came up with a pretty nice concept. As I said before, we have 10 push buttons on the soundboard. We dedicated one of them for entering the menu and switching pages, so the other 9 buttons give you direct access to 9 of the samples. You basically have to pull the soundboard out of your pocket, and then you can directly play a sample with them. The one button can change pages. We marked them with a red, green and blue LED. And so you have 9 times 3, 27 samples that you can access fairly quickly. We had a lot of ideas of stuff that we wanted to put on the soundboard for our flatmate, and different samples, even entire songs. And 27 buttons weren't nearly enough for that. So what we did was we implemented 9 additional special pages where you have to press a combination of this menu button and one of the 9 sample buttons. And then you can access another 9 times 9 samples that aren't as quickly accessible as the others, but still you have kind of that space on the soundboard to put them on there and play them at will. And you can, of course, exchange all of the samples, the quick ones as well as the special pages, by just swapping out the samples on the SD card. And yeah, that's basically it. You can take your favorite samples with you everywhere, anytime. Last but not least, you are, of course, able to change the volume of the soundboard with a key combination. This basically wraps up the mechanical and the electronical aspects of the soundboard. Despite the many setbacks and complications during building this thing, we had a lot of fun and we learned a lot, and we are really happy with the result. The sample playback is loud and clear, the design is phenomenal, and the wooden housing in combination with this acrylic glass lid gives the whole thing a really nice look and feel. After having spent almost 6 full days building this soundboard for our flatmate's birthday, we wrapped it up by spending another few hours here in my studio and searching for a few samples that were either just funny or even insider jokes with our friend. We gave it to him and he really liked it, and we spent like half an hour in the kitchen of our flat just going through all of the samples and laughing about them, and telling him all the cool features of his new birthday present, and we're really happy that all that hard work paid out. Now, during making this soundboard for our flatmate, we all thought, maybe it would be nice to have one of those for ourselves as well. So what I did was I started designing a new printed circuit board for a version 2 of this soundboard. And that would make it so that we can assemble more of these in a shorter amount of time and debug it a bit quicker. So I have a sneak peek for you here. It's this small 3D printed prototyping housing of the version 2 soundboard. So while there's only one of these, I've already made 5 of these and can maybe give them to all of my flatmates soon. As I said, I'm still debugging and trying to get it to work in all of the aspects, but we have more buttons on this one, different features, and if you're interested in seeing more of the details about this version 2 and maybe building one of your own, then please write it in the comments and I'm happy to share the schematics and the software with you. That's the end of today's project video. I hope you enjoyed it, and if you want to see more of this kind of electronics and technology stuff, and also woodworking and fun crazy machines, then please subscribe to stay up to date when we post another video. We hope to see you there. See you soon and stay creative. Bye. And please subscribe!